Okay, honors physics students, and maybe even some parents. How about some hints for worksheet number 1? And here goes. They'll be kind of random, but you can handle random. How about number 3? Number 3 has a graph that looks kind of like you see it. The velocity starts at negative 22 meters per second, and so you could record here the negative 22. Understand that it slows down to negative 8. So somewhere around here is your deceleration. Well, it asks for some questions. Like, for instance, one of the first things it asks for is the acceleration during the time when it's constant velocity. So you're finding the slope of that. One of the most important questions is, what's the acceleration when stopping? That's right here. So you find the slope of that. Now the slope is just the rise over run. Well, what's the rise? So it starts right there at negative 8 and ends at 0. So the rise is just 8, isn't it? And so then you might say, well, what's next? What's the run? The run is only 0.3 seconds. So try the rise over the run, and you can find the slope. Another question it asks is the displacement from 0 to 4.5. Well, why not find the displacement? The displacement would just be the area under the graph during that time. So you are going to find the area of a rectangle, another rectangle, a little triangle, and put all those together. Notice that's going to be a negative. Let's continue. Number 4. Number 4, you're riding your bike from John's house to Tom's house. Understand, this is supposed to be a velocity graph. Velocity is from the position graph. So here is the position graph. To find the velocity graph, it would be really useful to have the times match up. This is a position graph, this is a velocity graph. The slope is the rise over run. So when you find the rise over run, again, you need to make sure the units match up. But this is a constant velocity of 7.5 miles an hour. Notice that it jumps dramatically to a large velocity there. It jumps almost immediately way up and only lasts a little bit of time. Then what kind of slope does it have there? It has 0. So that should help you on problem number 4. Let's look at number 5. Number 5 asks for the displacement. Now this is a velocity versus time graph. The displacement is the area under the graph. Well, how do you find the area under the graph? You could count the squares, but another way is to make it into a triangle, like I've done. So as I did this 1/2 base times height, the mathematics is much easier. There's a little hint. Number 6, when you're driving through a village, usually the velocities are constant at first, so you have the constant velocity there. Notice that you'll have to slow down to a slower velocity, but then you drive at a constant velocity there. Produce from this the position versus time graph. And just one hint to get you started on this one. Well, because this is a constant velocity, the position graph is increasing very steadily, very steeply, because you're going very fast. Then what happens there when you have a constant velocity? You have a position graph that is increasing but not as much. This should help you finalize worksheet number 1. Nice job.